Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 326, I chat with Robert McKinley and Mike Skrzat of Datasat about their really cool products and how they are used to tune big and small rooms. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 20th, 2016. Episode 326, Digging into Datasat. This episode of Home Theater Geeks is brought to you by Optical Cables by Corning. Corning's incredibly durable Thunderbolt and USB 3-point optical cables are longer, thinner, lighter, and stronger. Go to opticalcablesbycorning.com to learn more. And by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/ecotank to find out more. Hey there, Scott Wilkinson here, the home theater geek and editor of avsforum.com. This week's guest geeks are Robert McKinley. He's an executive vice president at Datasat Digital. Hey, Robert, welcome to the show.
Hey, thanks for having us.
My pleasure. And also Mike Skrzat, a field engineer at Datasat. Mike, glad to have you with us.
Hi, Scott.
Those of you who are watching live at live.twit.tv can post questions as we go in the chat room. And you can join the chat room there at live.twit.tv, or you can go to irc.twit.tv. Just include my name, my screen name, which is my name, Scott Wilkinson, no dots or dashes or spaces, in your message, and then it'll show up in a different color on my screen. My eye will be more easily drawn toward it. And I'm sure there will be some questions here because we're going to be talking about the company Datasat and its impact on commercial and residential theater systems. So, Robert, let's start with you and give us a brief history of Datasat, how it got started, what was its original mandate, and how has that changed over the years?
Well, sure. I mean, actually, we started back in 1993. A good portion of us that are working for Datasat now started Digital Theater Systems, which later became DTS. So our mandate back then when we started as DTS was very simple. We had to get 1,000 units built, engineered, built, and out into the field in support of Jurassic Park. We did that, and with DTS, the cinema division grew over the years. The group that is in Datasat is the same group that largely engineered those products, built them, did a lot of the design work, and actually produced them, sent them out, and supported them over the last, 23 years.
Mm. The first, you said the first movie that used DTS as a soundtrack format was Jurassic Park, huh?
That is correct. June 11th, 1993. I remember most of us stayed up all night long when that movie was first released to make sure that everything worked smoothly, and fortunately it did. And, that's kind of the history. That's where we came from.
Okay. All right.
So in 1997, that technology that was invented to support that movie and other movies won an Academy Award, which is a great technical achievement at the time. And moving forward in 2008, DTS had already started the consumer technology division. They decided as a public company that they wanted to sell off the cinema division. So Datasat came into the picture. Our owner, Phil Emmel, owned a company named Datasat Communications in the UK, a secure, high-profile satellite delivery company. He bought the cinema division of Digital Theater Systems. We became Datasat Digital Entertainment. And even though we were largely focused on cinema at that time, and we built and supported over 30,000 processors and playback devices in the professional cinema space, we decided somewhere around in the 2011, 2012 range, a lot of people were asking, why don't you build something for consumer? Why don't you build something for consumer? So we started down that path, and we created what is our flagship product, the RS-20i, out of the cinema technology that we developed over the last 17 or 18 years. So that's really kind of the evolution of the company, where we became Datasat. And our focus now will always be in cinema, but our focus now is largely, if not mainly, on the consumer space. And we're really happy to be there. It's a great industry to be in. The people are great. We've received a lot of super positive response. And the products are great. They speak for themselves largely, but we're going to be talking about them today.
Yes, we sure are. And it's funny, because when I go out to the movies, and I do go out to the movies, unlike some people with home theaters, I see Datasat, the name, at the end as one of the sort of technology providers. So you must be in an awful lot of theaters by now, right?
Yeah, the actual the units that we manufacture, like I said, we're in over 30,000 cinemas worldwide.
Oh, yeah, you did mention that.
Yeah, one of the things that I didn't touch on was actually the technology that gets us the credit at the end of the film. Because the playback was done over CD-ROM and all of the encoding was done, and then our unit also decoded it, it's that encoding technology that gets our credit at the end of the movies. So virtually from 1993 on, we've been in almost 100%, and I say almost because it's not 100%, but almost 100% of all major Hollywood releases and international releases over that period of time.
Now, do those releases get different encodings from Datasat or DTS, from Dolby, and so on and so forth? Do they have to kind of make several copies of the movie with these different encodings on them, or can they coexist?
They coexist. Our technology was based off a time code, which is striped onto the film during the manufacturing process. Dolby's information for their digital playback presentation was actually also placed onto the film in a different area. So there was actually three technologies that coexisted for cinema playback, and that's DTS, Dolby, and also Sony had one as well.
Oh, yeah, SDDS, exactly.
Correct.
And yet now we don't have film mostly. I mean, most cinemas are digital. So how does that work? How did that transition occur?
Well, we heard that coming for a long time. And of course, being in the business, we actually had some digital cinema offerings with regards to servers and looking at the DCI compliance and all that. We knew that film was going to retire. We don't think it's ever going to go away completely because, of course, we've supported a lot of really major 70 millimeter releases, and we're the only company that can do that, and we still enjoy that. We're still geeks about doing film. We love it. So as digital cinema comes on board, this is where we shifted our focus away from the playback devices and more into the audio processing side. Because all of our engineers here, I mean, they've been doing this since 93, 94, 95. They've got a lot of technical expertise in the area, so they've leveraged all of that expertise over that period of time and put it into the audio processing for the consumer space.
Good Sound in the chat room is asking, does the soundtrack still reside on CD-ROM even in this era of digital?
No, it does not. Everything in the digital era is actually on the it's on the digital copy.
Okay, so it's on the hard disk that gets delivered to the theaters, which is how
it's on the DCP.
DCP. Okay, very good. So, Mike, I wanted to bring you in on the conversation here. Talk about a little bit more detail about some of the technologies that Datasat and DTS developed over these last, 20-some years.
Well, the playback systems go way back to 1993. And like Robert was saying, we're basically on every movie that came out since that time. After that, we developed several cinema processors that were in motion pictures theaters all over the world. Some of these were being used in home theaters. Our most recent device, the AP20, is considered the best sounding cinema processor in the world. And that was being put into high-end homes like movie stars. And from that, we ended up building the RS-20, which is very closely based on that, but it has even more technology than the movie system. It has several more Shark processors in it for a total of 9 Shark processors. It has more advanced base management. It has a linear power supply instead of a digital supply, better volume chips, and is basically, we feel it's the best sounding box on the planet.
We have a picture of the AP20, which I guess is your current cinema processor. But you mentioned Shark processors. There it is. And that's what you would find mostly in commercial cinemas, but in a few very high-end home theaters as well. As you say, movie stars, probably directors, people with lots of money.
Well, we actually have 9 Shark processors in this box, which is quite a few more than anybody else has in any piece of equipment.
Now, I should say that the Shark processor is from Analog Devices, I believe.
That's right.
Correct.
Yeah. And that's basically and mostly an audio processor, right? Shark is SHARC, and it stands for something I don't remember. But it's a pretty high-end, well-respected audio processor. I don't think it does any video, does it?
No, it's just a audio DSP.
Mm-hmm. And with 9 of them in there, you're right. You've got some pretty amazing computer power to do some amazing things. So what are some of the things that this processor needs to be able to do?
Well, beyond what most processors do, it's able to route any of the channels to any other channel. It can do crossovers. I can rotate a room. So I have some rooms that have a projection screen on the front and maybe a plasma screen or an LCD screen on the side wall. They can rotate the entire sound system with different EQ, different processing, different delays, everything completely different from one, to be able to view the movie from a different angle. I also do a lot of rooms. Every single input button could have its own separate EQ, separate delays, separate decoding, separate base management. Everything that makes that box unique could be completely different on every button. So I have rooms that have, I have one place that has a great room that includes a dining area in one part of it, a theater in the main part of it, and a kitchen in the back. Each one of these can have a completely different setup. And this place in particular has an automation system that monitors where you are in the room, and it'll actually automatically change everything just on the position that somebody is in the room.
Mm-hmm. Mike Heiss in the chat room is mentioning that Denon and Marantz also use Shark for DSP, and they're probably not the only ones. But you guys have implemented a much more powerful system here by combining many more of them than would be in a typical AV receiver, say.
Yeah, typically there's 1 or 2, perhaps 3. Nobody uses anywhere close to 9.
Mm-hmm. Good sound in the chat room. Or I'm sorry, SSB 201. I'm tired of all these 11 or 13 channel home processors, home receivers. I want 20 plus channels. And that's really one of your hallmarks, or Datasat's hallmarks with these processors, is that you can do many more than the 5.1 or 7.1 kinds of surround systems, correct?
That's correct. We can do Atmos, we can do Oro. Those can go up to 13.3 or 11.4. And we can also add another 8 channels to the output, so we can parallel channels and have different DSP taking place in those channels also.
Mm-hmm. Well, I want to get to immersive audio in a minute, but first, I want to ask, when I was reading the Datasat website, one of the things that was pointed out, or one of the items that was there, was room optimization for the largest possible sweet spot. And I would love for one of you to talk about exactly what that means and how you achieve it.
Well, our units all feature Dirac Live, And Dirac Live utilizes a single microphone in multiple positions, and you can take up to 9 measurements with that microphone. Each one is weighted against the others, and you can optimize as much of an area of the room as you like. We usually keep that in the middle third, but you can also bring that down to a single spot if you wanted to, depending how focused you want that sweet spot to be.
Sure, but I mean, in a commercial cinema, you do want it to be as wide as possible because you've got a huge room.
That's correct. So typically, most theaters utilize a 4-microphone multiplex system. With the Dirac, we can actually take 9 measurements in that same area and have it more equally spread out and not have little peaks and valleys that are prevalent in one spot affect the room as much as a 4-microphone setup.
But you said they're sequential. You put one microphone up, you take a measurement, then another one, or you put the same one in different locations, I should say. Is there any way to like do 9 of them at once?
Not really. It only takes, if you're doing a 13.1 system, it takes about 3 minutes to do a complete measurement of all the channels and then move on to the next position. So the microphones are rather expensive, and if we had 9 of those, it would be
it'd be quite an investment.
as expensive.
Yeah,
exactly.
Okay, all right, I got you. Well, why did I don't think that DTS or Datasat invented Dirac. That came from someplace else, right?
Dirac is a licensed technology that we use. So,
right. So what?
We do
the question. Sorry.
We implement it with a lot of DSP horsepower, though. So that's one of the reasons why I think we sound better than most other companies that utilize Dirac.
The question is, why did you choose Dirac as opposed to some of the other options that are out there that might have been available? Trinoff, for example, Odyssey, which is typically used in kind of lower-end AV receivers, but still, there are a number of systems out there that one could have chosen.
We looked at quite a few systems at the time and found Dirac to be better than everything that was out there at that time. It also gives you the flexibility of having complete control over the target curve and to very quickly make modifications to that curve and upload them to our processors. So you can actually hear what the Dirac is doing and make changes to it to dial it in on that last little bit of it. It's not a auto system like Odyssey. It still requires input by the setup technician.
Mm-hmm. Well, we have some examples of some measurements of rooms that you've done, and we can go through them here. We can take a look at the numbered graphics, starting with number 1, which is, I believe, simply a low-frequency room, or a low-frequency response in a room. Tell us about what we're looking at here.
Well, this is basically the measurement that the Dirac has taken, utilizing whatever number of measurements that was used in this particular graph.
Is that one microphone there, or is that multiple, like an average of multiple microphones?
That's the average of all the measurements.
Okay.
You can also look at each of the measurements independently, or all of them piled on top of each other. And you also have complete control over what it's aiming to bring the curve to. So we call it the target curve.
Right, and that's the next one we have, is the same curve with the target overlaid.
That's correct, yes.
So we see in the original, in this measurement here, we see a hump at, I can't see the numbers exactly. Let me
yeah, it looks like it's at about 60 hertz
60.
is the peak of that, yeah.
And then there's another one at 30.
Mm-hmm. And we have
dip.
a little dip, yeah, and then we're dropping off. So so typically you don't want to put too much of a boost in the low end to get a lot of to make your speaker work too hard. So probably I would pull that in just slightly, but that's the option of whoever is setting the room up.
Right. Well, this was one thing I was going to mention. you know, if you've got a null or a dip in the base frequency response, it's almost impossible, as I've learned, to increase it by adding more to it, because it's more level to it, because it's still a dip. It has to do with the nature of the dimensions of the room and the frequency where it's at, and it's always going to dip there. And so if you keep boosting and boosting and boosting, you're really not going to solve the problem, are you?
Well, depending on the room, if you have a really big dip, it's always best to get your room sounding as good as you can get it sounding without just fixing it with EQ. However, the Dirac does a very good job, and it does it without causing any problems. It limits itself and doesn't try and put excessive EQ in any place. I've seen it do some pretty amazing things. But still, you don't want to have it fill a 22 dB hole in 30 hertz or something like that.
Right. Exactly. Much easier to cut than it is to boost, I think, generally speaking, but especially in terms of nulls.
Well, Dirac does a combination of boost and cut. And it does so with a set of rules that keeps it from putting excess EQ or it does it without hurting the signal.
Well, that's always the goal, isn't it? Let's take a look at I believe number 3 is the next graphic, which is similar to this. It shows us the post-processing result along with the target curve. And then I think number 4 probably shows us the post-processing result without the target curve. So
correct.
Look at that. That's amazing. I mean, it's virtually flat.
It is. The other thing it does is both impulse correction and also phase correction. So where you're normally putting EQ in the circuit, you're throwing phase distortion into the signal, and Dirac also takes that phase distortion back out, or any other phase distortion that's in the signal. So you get much better imaging and a much cleaner signal with better dialogue intelligibility.
Mm-hmm. Well, the dialogue wouldn't be in this frequency range particularly.
No, but
next we're going to take a look at a
Barry
full range.
White's.
Yeah, maybe Barry White is down there. Yeah, exactly. Well, we're next going to take a look at a full range example. But before we do, I would like to take a moment to thank one of our sponsors for this episode, which is Optical Cables by Corning. Corning can greatly improve your audio-video workflow with their strong, durable, and far-reaching Thunderbolt and USB 3.0 fiber optic cables. Whether you're into high-end video, photography, audio production, or computing, Optical Cables by Corning will allow you to build a convenient workspace through a superior long-distance connection. Corning's USB 3.0 and Thunderbolt cables are incredibly strong and flexible. They have exceptional cable runs of up to 60 meters or 200 feet for Thunderbolt and 50 meters or 165 feet for USB 3, making it so easy to move noisy, space-consuming devices away from your workspace. You can bend or walk on Corning cables, and even if they're tangled, it's no problem. They keep transmitting at top speed. Optical Cables by Corning will help you achieve acoustic and electrical isolation so you can enjoy a clutter-free, peaceful work environment. Now, one of the companies that uses Optical Cables by Corning is Universal Audio, which relies on these Optical Cables by Corning to achieve acoustic isolation in their studio where they test new equipment, such as their best-selling Thunderbolt audio interfaces. Now, when I used to work in the musical instrument or pro audio area, Universal Audio was one of the most respected companies in that area. So it's no wonder to me that they rely on Optical Cables by Corning. Instead of investing in multiple extenders, adapters, and cables, turn to Optical Cables by Corning to establish the connection you need with one simple, long-length cable. Optical Cables by Corning are available at all major electronics and professional AV retailers, including Apple stores, Amazon, B&H, and more. Optical Cables by Corning are longer, thinner, lighter, and stronger. Go to opticalcablesbycorning.com to learn more. And we thank Corning very much for their support of Home Theater Geeks. So I was just talking with Mike Skrzat, a field engineer at Datasat, about some examples of how Dirac Live, the room tuning algorithm that Datasat uses in its processors, how that can really improve the frequency response within a room. And we just took a look at an example of doing that just to the base frequencies, which is pretty important, especially in terms of room modes and so on. And I want to now get to a full range example. But before we do, let me ask you this, Mike. You tune a lot of rooms. This is your job, right, as a field engineer. Is it true, as I've often heard, that the low frequencies are the most problematic and typically need the most work?
Well, I wouldn't quite agree with that. Certainly there are problems in all frequency ranges, and getting the center channel to match the left and right speakers is very important. So when things are panning or dialogue is coming out, I would say that's even more important than the sub-bass channel.
Okay. Creamy Corncob is asking if we can go back to number 1, I think, or number 2. So at 32 hertz, where the lowest dip is in number 2 slide, or number 1, doesn't really matter. How do you flatten that to near 0 without boosting when cutting is ideal? This is a question that I sort of alluded to earlier, but maybe you could address it again.
Well, Dirac does boost, and it both lowers and raises whatever bands it's affecting through mixed mode filters.
So in other words, at that dip at 32, it would in fact boost that probably.
That is correct, and it would be bringing down that other peak that's off to the left of that also. So it does a combination of the two. Internally, the levels are brought down to a point where any boost in the signal is not going to cause any clipping internally in our unit.
Right, exactly. Okay, well, let's take a look at the full range example, which may give us some more insight into this idea that, you know, the rest of the frequency range is important as well. Tell us what we're looking at here.
Well, this is a measurement, and I can't tell from this picture exactly how many microphone measurements went into this, but this is a measurement of a full range speaker.
Okay, within a room.
Within a room, yeah.
And when you say speaker, do you mean you do one speaker at a time when you're doing this, or?
You do all speakers at the same time, but you look at one at a time, so you're not looking at all the measurements. You can also lock each of the speakers to the same target curve and see them overlaid on top of one another so that you can match them very precisely.
That must be a little confusing. I don't have a picture of that, but...
well, it can be, but...
Go ahead.
Mm-hmm. It can be a little confusing, but you could turn them off. You could turn any of them on and off at
easily.
any point.
Okay.
So you can look at them individually or as a group.
Now, Creamy Corncob in the chat room is saying that mid-range is a mess. And if we go back to that picture, we'll see that in fact it does kind of vary around quite a bit, and that would have some.
This is rather typical. Even the best speakers will look something like this. And a lot of this is room modes and reflections. And after Dirac is done, it will look quite different. I'm sure you have a slide coming up that'll show it after Dirac.
Exactly. Well, let's take a look at the next one, which I think superimposes the target curve. And this is the target curve you want.
Correct.
And then we take a look at the next one, and we will see the result of applying Dirac.
That's right.
Which is, again, really flat. And I think the last one is without the target curve.
That's right.
But, I mean, you know, the variation is, you know, less than a dB, it looks like to me.
And that's pretty typical. If it's down too far in any position, it won't bring it all the way up. If we're down over 10 dB, then you'll see a little dip where the big dip was at one point. So it won't try and put so much EQ on a channel that causes problems with that channel. It does a very good job at that.
Mm. Now, is this all automated, or is this something that you're doing manually?
Well, you're deciding on the mic position, so that's important. And you're also deciding on the target curve. One of the things Dirac tends to do is try and boost the bottom end of the signal, so it'll extend the low frequencies past where that driver is really comfortable doing that. So usually I will take that bottom end, the recommended target curve, and shave off that bottom end so it's not trying to extend the low frequency range of that speaker. All that information can then go to bass management, let the subwoofer take care of everything, say below 35, 40 hertz or something like that.
Mm-hmm. If we go back to that picture again, there was one other thing I wanted to mention here or ask you about, which is that it looks like the level slowly rises as you get lower in frequency. There's this kind of slight tilt to the result.
That's pretty typical. What we found, and I think most people do the same thing, is if there's a small peak in the bottom end and somewhat of a roll off in the top end, that's pretty much how those speakers sound. And if you just flatten it out perfectly flat, you're going to lose how those speakers are aimed at sounding in the first place. So mostly what we're doing here is we're filling in the peaks and valleys and making it a smooth response rather than trying to extend it or to just make it perfectly flat.
Now that you mentioned how the speaker is intended to sound, and that brings up another question for me, which is each speaker manufacturer has maybe a particular characteristic type of sound that they voiced the speaker for. Mm-hmm. And doesn't this kind of wipe that out?
Well, I wouldn't say it wipes it out, because that's kind of what I'm aiming for to begin with, is to sort of keep that tonal quality of that speaker and not just erase it and make it perfectly flat.
Well, but that example we just saw was essentially perfectly flat. And
well, it is like you were mentioning. There's a little bit of a slope up in the bottom end, and also the roll off at the top end. So that's all part of the speaker, and I try and maintain some of that, and not just make a flat line out of the speaker.
Mm-hmm. This leads me to another question I'd love to ask both of you, actually. I see now that the high end rolled off after about 10 kilohertz, going down pretty far by the time you get to 20. Now we have speakers and content that we call high-res audio, right, that goes out beyond 20K. Have you ever dealt with that, and how can Dirac deal with that?
Dirac goes out to about 20K, so there's not really, it's not doing anything beyond that point. You'll notice in that graph there's a little line on each end. Let's see, not on that one. If you go back to the target curve, I think you'll see this.
There you go.
So that little line where it's darker on the left and darker on the right is where Dirac stops doing anything. At that point, the signal is left alone, and there's no manipulation taking place by Dirac. On the low end, most speakers do roll off quite a bit by the time you're getting up to 20 kilohertz. There are some that don't, but that's pretty typical, that there's going to be a fair amount of roll off. And if you boost that up too much, it's just not going to sound good. It's going to sound too bright, and it's going to sound brittle.
Understood.
And one thing to add as well, keep in mind these are target curves, and these are used as example for what Dirac is capable of. To maintain specific characteristics of a speaker, you can put in a target curve that matches the manufacturer's speaker curve exactly if you wanted to. And so you don't have to flatten it out. You can also raise the high end up. If the signal's there, then you can work with it. But if the signal's not there to begin with, if the speaker's not reproducing, or if the room is killing it, then of course it compensates accordingly. But if a particular speaker manufacturer has a little kick up at 100 cycles, or a little dip at 3K, you can match that in the target curve and overcome the obstacles in the room and still let the speaker have its individual characteristics.
Mm-hmm.
You notice those little red dots on the target curve.
I was about to ask about that, yes.
Yeah, each one of those is a point that you can grab and manipulate. And if there's not a dot in any position you want it in, if you double-click on the curve, you'll add another dot to it. So you can bring those points to anywhere you want and really make it look like anything you want. And if you had a dip, maybe you didn't want to take all the way out, you could build some of that dip into the target curve and not have it do as much work in that area. The other thing about these dots is once you listen to the material, you still have complete control to go back in, make changes to it, and then have it re-optimize and send another Dirac to the playback equipment, and then compare those two and see if it's more to your liking or the customer's liking, because a lot of this stuff gets dialed in to the customer's taste also.
Sure. Well, that was my next question, in fact. Like we do with video calibration, you measure stuff and you tweak things until the measurements look good, but then you look at real content and you might adjust things away from where they were when the measurements were best because it looks better, just to the eye, real content. So my question to you is, does something similar happen here? You measure, I assume you're measuring with test tones, pink noise or something like that, and you get these nice flat curves. And then do you listen to it and go, wow, you know what? That really sounds weak in this range, or I'd like to have more of this. Again, probably the customer's taste is obviously paramount, but do you often find that you deviate from this measured perfection or close to perfection in order to get something that sounds better on real content to people who are listening to it?
Oh, certainly. The Dirac will get you 90% of the way there, just if you look at the curve and take your best guess at the curve, and then listen to it. Like anything, we listen to a lot of different material. We listen to movies, we listen to music, we listen to stuff we know well, and then we make changes to it. Same thing with the sub-bass level. What is measured is not, measurements don't always exactly equal the way things are perceived. So once you listen to them, that's when the final adjustments really occur.
Mm-hmm.
And I would add one other comment as well. The RS-20i has the unique capability of allowing you to overlay equalization on top of the Dirac as well. So while you set a room optimization with the Dirac, you can also use parametrics or graphics, shelving, high pass, low pass on top of that for particular types of content if you wanted, and save all that to memory settings in the box. So if you're listening to music and you want it to sound a certain way, or you're a fan of a certain style of music, you can equalize the room on top of the room optimization for that content, store it, and then you can do something different for movies. You can do something different for gaming, and it goes on and on. So we try to build as much flexibility into the equalization processing as we possibly could.
Mm-hmm. Well, speaking of that, I wanted to know, Robert, maybe you can address this, about the process of migrating what has been developed for commercial cinemas into home products. Is it just a direct transfer? Is there anything special you need to think about, different that needs to happen in a home environment versus a commercial environment?
Well, the size of the room is very different. One of the things that we do in the commercial environment is we will add extra surround speakers because of the, just the sheer length of many of the theaters and the size of them. So you will have mirrored surrounds as you go back so that everybody's listening experience is equal, or as equal as it can be. We got a lot of experience from doing audio processing in the movie theaters, and of course we brought that to the smaller rooms and the consumer market as well. It's all of that expertise went into it, but as far as it's different. But I'll let Mike talk to this because he's done a lot of cinemas around the world, as well as a lot of consumers and a lot of homes and different types of rooms. It all goes hands in hand, but I don't think it's really that different.
Mike, what do you say?
Well, the biggest difference between a small room and a large room is a near field environment. When you go into a far field environment, you have to put a curve into the room to make it sound normal. It's typically called the X curve in movie theaters, and it's 3 dB per octave roll off after 2K.
But isn't that for the speakers that are behind the screen? Or is that throughout the room?
It's throughout anything that's in the far field, basically. So
okay. Which a commercial cinema is. By the way, is there a clear definition of far field versus near field?
I'm not sure if there's a clear definition of it, but basically, in a large theater, something that's more than 100 seats, it's going to be a far field environment, and as you get smaller, the curve gets smaller, and until you're in a normal theater that somebody might have in their house, and then that's just all near field.
Right. Okay, so near field versus far field is one thing you have to do. But again, it's all target curves, and you can just use the X curve or not, depending on the size of the room you're in, right?
That's correct.
Yeah.
Yeah, that's just built into it. And the target curve just changes depending on if you're doing the X curve or not. Well, part of Dirac is you can save curves to Dirac, and one would be having an X curve built into it that you can just load as you take your measurements.
So there isn't really anything else that needed to change between your theater processor, commercial processor, and your home processors, right?
Well, actually, the home processor has a lot of changes to it over the theater processor. It has all the decoding, which we're not allowed to use in the motion picture theaters because we're a competitor with Dolby in that market. So we have the full Dolby home suite, including Atmos and everything, in our home processors that aren't in our movie theater processors. Also, we have very advanced base management in our home processors, which isn't really required in movie theaters because they're all full-range speakers pretty much.
Although they do have subwoofers as well, don't they?
Well, they do, but they're not using base management for the most part on that, aside from maybe on the surrounds. The screen channels all can handle down to 25 hertz, so there's not usually a problem with having to reroute information over to the subwoofers.
Right. So the subwoofers in the commercial environment are really only doing LFE, low frequency effects.
That's correct.
Which is on a separate channel, and there are things like rocket blast-offs and explosions and that kind of thing.
All that's going through the LFE channel, although Atmos now uses some subwoofers in the surrounds to give them a broader range. But generally speaking, most theaters just have the LFE channel going to the subwoofers. Right.
So talk to us a bit about immersive audio. We now have basically 3 formats. We have Dolby Atmos, DTS:X, and Oro 3D. And I think Atmos probably has the most installations in commercial cinemas, if I'm not mistaken, followed, I don't know whether Oro or DTS:X. DTS:X was kind of late to the game, weren't they, in terms of immersive audio?
Yeah, that's correct. The DTS is coming out now, basically. And I believe Dolby has the most installations with Atmos. Between Atmos and DTS:X are both object-oriented systems where an object is basically programmed into a position, and then depending on the speakers you have available, it's rendered to that position, where Oro is a recorded format, so everything is mixed into the speaker setup that you have on the mixing stage.
I thought that they were working at least toward having a more object-based system at some point. Has that not happened yet?
I think Oro is doing that, but I can't really speak too much for where that's at the moment. Yeah.
Okay, I got it.
But any of the immersive environments just add that third layer to everything that makes you more there.
Yeah.
It gives you that emotional impact that you're surrounded by the sound and it's coming from all directions, just like it does when you're outside or in a concert venue or a church or wherever you may be. There's that height that you don't get if you just have a 5.1 or a 7.1 system.
Mm-hmm. Do you have a favorite of any of these systems, or do they all work more or less equally well, in your opinion?
Well, I think they all work pretty much the same. I haven't had enough experience with DTS-X yet. We did our first demo, but that demo material was pretty spectacular. But I think generally they're similar, at least. You know, they each have their strong points, but I think they're close enough where it's not really one outweighs the other one by any large amount.
Sure. Certainly, Oro has the idea of putting the height speakers no more than 30 degrees above the plane of where your ears are, whereas Atmos puts them clear overhead, almost like at a 90-degree angle. So what are your thoughts on that?
Well, Oro also has a Voice of God speaker available, but not everything is
straight
mixed
overhead,
with that. Yeah, so it all pretty much just works out. I don't see a huge difference between each of the systems. They're all quite good.
Yeah, one of the things.
Sorry, go ahead, Robert.
Yeah, I was going to say one of the things with these technologies, I mean, we need to be fairly technology agnostic, and we want to offer the superior experiences wherever we can. So that's why we work with all the manufacturers. And we had Oro in our box first because we did have a relationship with them on the commercial side in professional cinemas, because we actually manufactured a version of our AP20 box for Barco, who was doing the Oro installations in the commercial space. Right. That being said, we used to work at DTS, and we're very familiar with those guys. So as soon as X came on board, we were on top of that. And then we also love Dolby Atmos. It's one of the beauties. We can add these technologies fairly easily to a box. People, they don't have to go out and buy a new RS20i. All of these things are add-ons either through hardware, through a slide-in card, or through firmware updates.
Mm-hmm.
And they're all great.
I've heard them all, and I agree. They're all very effective. We're going to talk more about those products in just a second, but if you'll allow me a moment to thank our other sponsor for this episode, that's Epson. Now, Epson's revolutionary cartridge-free EcoTank line of printers for home and office introduce a new age in printing. The EcoTank ET4550 wireless all-in-one printer doesn't use ink cartridges. It features an amazing, innovative, refillable ink tank, earning it the title of CES 2016 Innovation Awards honoree. So you have no more out-of-ink frustration. It includes up to 2 years of ink, equal to about 11,000 black pages or 8,500 color pages. You can save up to 80% on ink with low-cost replacement bottles. It's powered by Precision Core printing technology. It has auto two-sided printing and a 30-page auto document feeder, and easy wireless printing from tablets and smartphones. All EcoTank printers deliver an unbeatable combination of convenience and value. With Epson's EcoTank line of printers, you'll have the freedom to print without running out of ink. In fact, the Epson EcoTank system was named the 2016 Small Biz Windows Printer of the Year. So visit epson.com/ecotank today to transform the way your home, office, or work group prints. For the best combination of ease and value, turn to the Epson EcoTank printers. That's epson.com/ecotank. And we thank Epson very much for their support of Home Theater Geeks. Epson, exceed your vision. So I wanted to ask you, Robert, about the products that you have now available. We talked about the AP20, which is the cinema processor, and I'm not sure if we ever saw a picture of that, but I wanted to just show a picture. Oh, I guess we did. Yeah, there it is. Which a number of very well-heeled people put in their home theaters, but now we have products that are specifically for the home theater. starting with the RS-20i, which I've known about for, I don't know, it's 3 or 4 years anyway, and very highly regarded. And how did that one come about? Here's a picture of it.
Yeah, the RS-20i is our flagship product, and we started to get a lot of requests from people that wanted to put the AP20 in their homes, and it was actually a rather small group of people that said, hey, you guys ought to take your box and put it at CEDIA and see what kind of reaction you get. So that's exactly what we did. And
that must be where I first saw it. I think I first saw it at CEDIA 3 or 4 years ago, right?
Right. It would have been 4 years ago. And the reaction was overwhelming. I mean, a lot of people were... The whole idea of a touchscreen on the front panel was fairly new. The type of connectivity that we used was fairly new. And some of those are carryovers from the cinema side. But at the same time, the touchscreen proved to be a very useful tool and setup. And, of course, you can do it with an iPad or an iPhone or a computer as well. We took that kind of momentum back home with us, and we revamped a lot of the circuitry, as Mike mentioned earlier, changed out the power supply, changed capacitors, resistors. We went in, and optimized the op amps and the DACs. And we made sure that our engineers made sure they picked parts that worked very well in concert with each other so that we had the best sound quality that we possibly can. So when we actually released the RS-20i the next year as a true product for that for the consumer space, again, the reaction was overwhelming, and we got a lot of accolades for it, and people loved it, and they said, it's great. When are you going to come out with something else?
People are never satisfied, are they?
I mean, it was like, great, now what? And
yeah.
As I kind of alluded to earlier, we built the RS-20i and actually the AP20 as well with the idea that it would be upgradable so that it's at a price point where you don't want to be changing processors out as new technology comes on board. So
and in fact, we have a picture of the back panel I want to show while you're talking about this.
Perfect. So we put expansion slots in it, and the card that you see right at the top there, kind of in the center towards the left, is actually the Dolby Digital card that we came out with, because when we first released it, Dolby Digital hadn't really True HD hadn't come fully on board yet. So that was the first card that we did. Then we did a 8-channel expansion card for it. Then we did the card that contains the Atmos. The Oro was a firmware update to that. We've increased the bass management capabilities. Now we're adding X to that card as well. And I mean, actually, people that still love film, we actually have a card that is a film card that you can put in it, so you can take the optical tracks from the film as well.
Now that's for a home theater that actually does film projection?
Sure. If you've ever heard of the Bel Air circuit, where we have a lot of people that are in the industry, producers, directors, top name actors, musicians, they'll actually have digital cinema and film in their home. And so they'll want to be able to hook things up either digitally or optically, and we can do both of those for them. We're one of the few companies that can do that. So that was kind of where we wanted to go with this box. And of course, the next thing we came out with.
Hang on. Before you get to the next thing, I just wanted to mention, when I looked at this picture, I thought it was very interesting that the outputs are on these, I don't know what, DB something or another, connectors, and I guess you need breakout cables in order to have the actual outputs going to amplifiers, right?
That is correct. They're DB25 connectors.
DB25.
And we did that for a number of reasons. And first, it saves a lot of space rather than having a lot of XLRs on the back. The connectivity doesn't suffer at all. And to get in one of our other products real quick here, the amplifiers that we came at actually have a DB25 to DB25 jump, so it's a very nice, clean, easy connection, and then the channels are assignable on the amplifiers as well.
Oh, okay. We do have a picture of the amplifiers. I just want to quickly mention that the RA2400 and RA7300. These are 2-channel and 7-channel amps. By the way, I have to tell you, I love the industrial design. The front faceplate on these things, very attractive. Not that
Thank
that
you very
matters
much.
particularly, but it's really cool.
Well, it does matter. I mean, curb appeal and the visual of the product is very important. I mean, in this price range, people are proud of what they have. They want to show it off. We wanted to have a very good look to the product. So we went to the right people to design the style of these panels for us.
And we have the back panel of this too. I wanted to just briefly show that with the DB25s. Okay, this is the back panel of the 7-channel amp.
Correct.
And you've got the DB25s, I guess, at the bottom of the input stack of those XLRs.
That's correct. And you'll see the dip switches, which can assign the channels as well.
Okay.
So you really here you have the best of both worlds.
Yeah, it seems like it. You could connect directly. If you have an RS-20i and one of these amplifiers or more, you can connect them DB25 to DB25 directly and not have to go through any kind of connection conversion, right?
That is correct.
Mm-hmm.
And then you have an in and an out as well, so you can have multiple amplifiers, and again, assignable, because the RS-20i is a 16-channel box. Stock as it comes with the 8-channel upgrade card, you can have up to 24 output channels.
Mm-hmm. Well, tell us then about the newer product that came after the RS-20i.
Well, we had a lot of requests to come out with a product that was in a different price point, but yet maintain the same audio quality as the RS-20i. So our engineers went about designing what we call the LS10. It's 15 channels. It's got some dedicated sub-channels. That unit will also have Oro, Atmos, and DTSX. We've recently added Dirac Live to this unit as well. And it's at a little bit different price point. It's a little bit smaller unit. Great response to this unit as well. I remember when this product was in development, and it's an interesting story because, we were trying to build it to a certain price point, and we listened to it, and there's many of us here that just kind of listened to it and went, well, not quite there yet. There's some things that we need to do. And ultimately, we just said, forget it. It needs to sound good. That's the most important thing that we possibly can do. The quality of the box has to be equal to that of the RS-20i. So it is actually using the same op amps and DACs and a lot of the same resistor packs and capacitors as the RS-20i. So the sound quality difference is minimal. And so when we demo this box to people, when people actually hear it, they're quite surprised at the audio quality of this unit as well.
Now, I noticed on the back panel, we were just looking at that a second ago, the inputs are now on XLRs. They're balanced, or outputs, outputs. They're balanced, but they're not on these DB25s. I suppose that was a cost-saving measure, right?
Well, a little bit. First of all, they fit on the panel, which made it a little bit easier. And this product was a ground-up design, which also made it a little bit easier to include the XLRs. We had a lot of people asking for XLRs in this price range, so that's what we stayed with.
Okay, so let me ask you the question. What is the price range we're talking about here? I mean, I know we're talking about expensive stuff. The RS-20i and the LS10, which is somewhat less, but still expensive. I mean, what are we talking about here?
Well, the RS-20i is $23,000 retail, and the LS10 is anywhere from around the 13, 14 range up to 17, depending on what technology is in the box.
So definitely not a casual purchase, not for a basic home theater. This is high-end stuff.
It is high-end stuff, but it's surprising to see how many we sell into. I'm going to say, people that are very, very passionate about their audio quality, and that's where they're going to put all their money. They care about the sound. They care about the audio quality. And these are some of our biggest fans as well. We have them in, multi-million dollar homes, and we have them in track homes as well.
Oh, no kidding.
Sure.
Wow. Another thing about the LS10, I was going to say another thing with the LS10 is that it does not have those expansion slots like the RS-20i.
That is correct.
Mm-hmm. Mike, you had something to say?
I was just going to say the audio quality on both of these boxes is on par with some of the best 2-channel analog equipment on the planet. And it's not just a movie system. It is one of the best sounding music preamps that you can buy. period.
Do they have analog inputs for the analogo files? I mean, clearly I saw on the LS10, you got a bunch of HDMI inputs. So that's clearly meant for HDMI sources, digital sources. What about analog sources? I mean, you mentioned this comes in at the same kind of quality level as, analog preamps. And that leads to the question of analog inputs, analog processing. Do you have a straight through without any conversion to digital or any of that?
No, it's all digital, but this box sounds as good as just about any analog preamp on the market, even though it's all digital. Coming in through, we have 2 RCA inputs. We have 2 Toslink into coax inputs, and then the XLRs. So, but the sound quality of this box and the RS-20 are just unbelievable for a digital box, better than almost all analog processors out there.
Yep. Mike, just a quick question from me to you. The stereo ins are analog on the LS10, aren't they? They're
in, but they're digitized. They're not going through the box analog. Everything that goes through the box has been has come out, has gone through a digital transition.
A digital conversion.
Correct. And on the RS-20i, it does have 8 channels of analog in as well, but they're converted right upon input.
I might note that the HDMI inputs are some of the best of anywhere. We've had a couple of reviews in magazines that said they don't even test the HDMI inputs, and I recommended that they did, and both magazines said this was the first time they've ever seen HDMI inputs that sounded better than either the analog or SPDIF or Toslink.
Boy, and if those magazines happen to be ones that tout the value of analog electronics and direct pass-through and not wanting to make any of these conversions, that's really saying something.
It is, yeah.
Well, I got a couple questions in the chat room here that are going to kind of range about back to a little bit what we were talking about before. NLE guy is asking, back to those charts, those frequency response charts we were looking at, what is the content you're playing, that you're measuring? Is it a tone?
It's a sweep. So each channel has a sweep that lasts probably 15 seconds, and then it moves on to the next channel. And so
it's a sweep of frequencies from low to high. It's not pink noise or some kind of noise where all frequencies are in there simultaneously.
That's correct. It's a sweep that runs from, I believe, down to 0 hertz up to something above 20 kilohertz.
And why do a sweep instead of pink noise? Because with a lot of these other systems in AVRs, they'll put pink noise through the speakers and measure that.
Well, the direct technology is technology we license, so that's a decision that's made by Dirac to use the sweep. Originally, Dirac 1 used a pink noise with an embedded marker signal, and now they're using the sweep, which turns out to be much faster.
Okay. NLE guy also poses this question. So I'm not sure I understand the question. Sweating on near field will never reproduce correctly on in a far field venue. I've been talking with a number of movie mixers who have all said that one of the big differences of mixing for a movie and mixing for home is that far field near field difference. And so the question, I guess, is if you were to set it up for near field, you then it wouldn't work on far field. You'd have to reset it up in a far field environment, right?
Well, basically where the X curve came from was I believe in the 60s or 70s, Dolby went out into the field and set up a mixing console in a movie theater. And they had the near field speakers there, and then they played the same material on the far field speakers, and they matched an EQ. They came up with the X curve that made each set of speakers sound similar to one another when this EQ was applied. And that's where the X curve came from.
Which is the sort of difference then between the near and the far field.
Correct.
Emily the Strange asks, what type of material or media do you use to test with. Now, the testing, the measurements are these sweeps. But do you have any favorite content that you like to listen to that exercises the full range?
Oh, a whole bunch of movies out there that are just great. What have I been using lately? The Eagles Hotel California is a very good piece. It's very good for getting the bass set up correctly. The DTS version is very good. And pretty much most of the action films out there that you know very well, especially ones that have Atmos content in them, are usually what I'm using to actually listen to the system after we've done the initial tune, and then maybe make some changes to it after listening to the material.
Mm-hmm. What kind of time does it take you typically to tune a room? You walk in, you start, and then when you're done, you walk out. How much time does that involve?
Well, typically it takes setup and measurements and initial target curve takes 2 to 3 hours, and then usually an hour to 4 hours worth of listening, depending on the room and how much dial-in it takes after that.
So we're talking 5-6 hours, something like that?
Typically, yes.
Typically, yeah, exactly. Well, it's been fascinating. I want to thank you both very much for being here. Learned an awful lot about Datasat and room tuning and Dirac Live. Boy, just great technologies that I know work very well. I've experienced them myself. Now, I want to make sure everybody understands that there are other products that use Dirac room processing, room tuning. Some of them much less expensive than the Datasat products, but there are different levels and different versions of Dirac that are implemented in different products. So they're not all created equal. And Robert, if I'm not mistaken, you guys have actually done some of your own tweaks to it to improve it for you to use in your products, right?
Absolutely. We were one of the earliest adopters of Dirac, and we worked very closely with their engineering team to develop our own application and our own instance of Dirac.
So it's possible to achieve many of the same benefits, but to get to the top of the mountain, so to speak, you really need something with a lot of horsepower, such as these Datasat products. So I want to thank you both very much for being here.
It's my pleasure. Thank you for having us.
Yeah, that's Robert McKinley and Mike. Sorry, I've forgotten your name. It's kind of an unusual. Skrzat. Yes, Mike Skrzat. The field service engineer, and Robert McKinley, executive VP at Datasat. You can, of course, find much more information at datasatdigital.com. You can always find me at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg. And on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Rich Chernock, Chief Science Officer of Triveni Digital. And he happens to also be the chair of one of the working groups in the Advanced Television Systems Committee, or ATSC, working on ATSC 3.0, the next generation of terrestrial broadcasting. So he's going to be here to talk about the standards and recommended practices and the state of development of ATSC 3.0. So that should be very interesting, and I do hope you will join me. Until then, geek out.